All right, today we're doing section 4.4. So we are doing more with proving triangles congruent. So your quiz that's coming up is going to have a few proofs on it. Most of them are not going to be very long, but I want you to be aware that they are coming. So today we are going to use sides and angles to prove congruence. But what we did on Friday just involved what? Just sides. Side, side, side. So we start off with our statements. Again, we said that we always start a proof with what we are given. So DF bisects CE and DC is congruent to DE. Our reason, of course, is given. Once we start a proof, then it might be helpful to look at each given and think about what else that might tell us or how we could mark our diagram. Atea, what does our given tell us? So that is important, and we can go ahead and use that. I don't know that that comes from our given, but Atea, why did you say that? What was your reason? Did I mishear you? Did you say FD is congruent to FD? Yeah. Okay. Caleb, can you help us out with a reason?
I'm just going to ask you a question. Can you take a picture of this?
Not right now. Let's get through this. Okay. Kara, what's our reason?
Reflexive property.
Good. So this is our reflexive property. It's important to be able to identify that, even though that didn't have to do with our givens. That's okay. We are going to need that. Majay, what comes from our givens?
CF is congruent to FE.
Good. So I would say that from our givens, we can conclude that CF is congruent to FE. Sydney, do you know why? Good. Definition of a bisector, or definition of bisect. So let's start marking our diagram with all these things that we know. So one of our givens was pretty direct. DC is congruent to DE. Those can each get a tick mark. I said that FD was congruent to itself by the reflexive property, so we can mark that. And finally, we said that CF is congruent to FE. That's our definition of a bisector. So if they tell us we have a bisector, we should be looking for what pieces are congruent to each other because of that. Now that we've made all these statements, what are we ready for? The proof. So our last statement should always come directly from what they asked us to prove. And we are ready for that. Triangle CDF is congruent to triangle EDF. Why is that? Side, 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 or SSS for short. If all three sides of one triangle are congruent to corresponding sides of another triangle, the triangles are congruent. So that's a quick recap of what we looked at on Friday. Do we have questions about it? Okay. Today, we are throwing some new letters in here. We have SAS. What do you think that stands for? Side, angle, side. You guys are so smart. What about HL? Any guesses? Ooh, close. Hypotenuse? Anybody know what the L stands for? Not length. Shorter word.
Leg.
A leg. Good. We have a hypotenuse and a leg, which this is going to refer to what kind of triangle? A right triangle. Good. So we'll see all that in a minute. Just seeing if we're using our deductive reasoning skills. So before we get into our new postulates and theorems, we need to talk about how we describe these figures. So in a right triangle, a side adjacent or next to adjacent to the right angle is called a leg. So given this diagram, triangle ABC, what sides would be legs? AB and BC. Those would be our legs. In a right triangle, the side opposite the right angle is called the hypotenuse. So from this diagram, what side is our hypotenuse?
AC.
Side AC. The last term is one that might be a little bit newer to us. The included angle is the angle between two given sides. So for example, sure, we could use any of the angles. Angle B is included between which two sides? AB and BC. Good. We could do this for any of the angles. It doesn't just have to be angle B. Any angle can be included. It's based on what sides you're looking at. Questions, concerns, or need more time with these terms? Okay. So we are asked to name the included angle between the given sides. So if it helps for you to highlight or mark the sides that they're talking about, you can do that. I'll use a highlighter because I can easily erase mine. If you want to just trace over them, that's fine. So what angle is included between sides AB and BC? Angle B. You could call it angle B, or if you really want to, you can name it with 3 letters and call it what? Angle ABC, or angle CBA. Any of these are talking about that same angle that occurs at vertex B. You would just need one of them. I'm just showing you all your options. All right, let's take away that and look at letter B. We're looking at sides AB and AC.
Angle A.
Good. Angle A is included between those sides. Again, if you want to list it with 3 letters, you can. Angle CAB or angle BAC. All of those refer to the same angle. Now you might be able to guess this last one, but if we look at sides AC and BC, the included angle is angle C, or you could call it ACB or angle BCA. Small typo in your notes, but I fixed it in the slideshow. It should say if, not it. If 2 sides and then the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then the 2 triangles are congruent. So even the way that it's listed, SAS, the angle is in between the 2 sides. Okay, angle has to be in between the sides we're talking about. So example 2 is a quick yes or no. Are they congruent using side angle side? What do you think about letter A? Why is the answer no?
Because it's not between, the angle's not between 2 sides.
Good, the angle's not included. This angle is not in between the sides that they marked in either triangle. So no, angle is not included. All right, what about letter B? Yes, on this one we've got 2 pairs of congruent sides. And the included angle is congruent on both of them. So I would say yes, side angle side would work. What about letter C? Why not? What is it, Micah? Good. It's because of the first triangle. The angle is not included on the first triangle. It was on the second one, but it has to be included on both of them. So this one is no. Angle not included on first triangle. Questions about what it means to be included? Ari, do you have a question? So one way to do it would be to highlight the sides that they're using, like we did on the last one. So if I highlight these two sides that they marked for me, is the angle that I highlighted the one that they marked? No, so it's not included. Does that make sense? Yeah. Okay, so if it helps to trace over them, you can do that. Ataya, did you have a question?
Yeah, okay, so you highlighted it, so what does it mean?
So the angle that I highlighted better be the one that I'm using. And in this case, it's not. They use this angle down at the bottom. So the included angle has to be used, so that's why
both of them?
On both of them.
Okay.
Yep. So here it worked because if I were to highlight those sides they used, I highlighted the angles they used. So that's the one that worked. Excuse me. On letter C, the second triangle it worked on, but on the first triangle it did not. Does that make sense?
Yeah.
Okay. Other questions? I know the idea of an included angle is new to us, but it's going to keep coming back. We're okay for now? All right, we'll keep moving. In the diagram, we are told that ABCD is a rectangle. Is triangle ABC, so that's the big one, top right, congruent to triangle CDA, that's the big triangle on the bottom left? Explain. So we don't necessarily need to write out a complete proof for this, but we should be able to walk through the explanation for it. First of all, what do we know about the sides of a rectangle?
Two sides, right? Two sides.
We're on the right track. Can you name a specific pair of sides that would be congruent from this picture? AB is congruent to DC. Anything else we know about the sides? AD is congruent to BC. Why do we know both of those things? Okay, it's part of the definition of a rectangle. If you have a rectangle, opposite sides are congruent. So for both of these, we could say something like opposite sides congruent in a rectangle. Yes, ma'am.
Is that something we can use like in a proof? We're trying to prove that the rectangle is congruent. We can say like the definition of a rectangle.
You could, yes, you could use a definition of a rectangle. That's fine. Or you could say opposite sides congruent in a rectangle, something along those lines. All right, so we've got some information. Now, technically, we could go about this the way we would have done it on Friday. And what would we have said on Friday?
The side thing with the A, C, they're reflexive, so they will be.
Right. So we could use the reflexive property to state AC is congruent to AC, and then use side, side, side. But there's something else we know about rectangles. What do we know about the angles in a rectangle? They're 90-degree angles, or they're right angles. So the ones that would help me the most in this case would be to talk about angles B and D. So again, this isn't a formal proof. We're just kind of talking about our explanation. So we could say angles B and D are right angles. Again, because it's a rectangle, we know we've got right angles. And then we could say that angle B is congruent to angle D because all right angles are congruent. We learned that a couple chapters ago. Now, what information? Well, so we have enough information to say that these are congruent using what postulate? SAS. So now we've got side, the angle in the middle, and the side. Side, angle in the middle, and the side. Again, if I were to highlight the sides that I'm using in each triangle, I would see that I'm using the angle that's in between those sides. Try not to connect them fully so we can see the two separate angles. So I could say that triangle ABC is congruent to triangle CDA using side angle side. Now, this is almost like having a two-column proof. It's just not quite as formal. Questions about all the steps we took to prove that those, or explain that those are congruent triangles? Okay, let's get into some actual proofs then. Again, we set up our columns. We should all be able to start it off. Statements, reasons. First thing I'm listing off in my statements would be what? My given statement. So JN congruent to LN and KN congruent to MN. If we want to go ahead and mark those in the diagram, we can. JN, LN, KN, MN. And of course we know all of that because it was given to us. Everyone is capable of getting some points on a proof. Can always start it off. Now we have to think, do our givens really help us get any other information in this case? Not really, right? We don't have any definitions to use. Ateo, what are you thinking we should do? Yes, I agree we need to use vertical angles. Could we name them a little easier? Good. Angle 1 and angle 2 are vertical angles. Does anybody remember why we can say that? It's not quite given, but it's close. Kobe? Good. We can assume that from the diagram. If they show us a diagram, we can see that angles 1 and 2 are vertical angles. So you could put assume from diagram or just diagram. We can tell those are vertical angles. Because they are vertical angles, what else do we know about them? They're congruent. So our third step would be to say angle 1 is congruent to angle 2. Our reason? I don't know that I would say definition. It was more of a theorem. Good. Vertical angle congruence theorem. Yes?
If we put like definition of vertical angles, would we get it wrong?
I'd probably be generous on that one if you're telling me they're vertical angles. The definition just sets up how they are laid out, like the fact that when two lines intersect, the non-adjacent angles, blah, blah, blah. So it was actually a theorem that told us that. So if you were to get vertical angles and this was a proof on a quiz, I'd maybe take off a half point, but I'll probably be a little generous on that. Even if you just said vertical angles, I'd probably be okay with that. It's just really not a definition. I know, proofs get a little nitpicky. Okay, so we could mark that in our diagram now that we've stated it. Our diagram's getting a little busy. Any thoughts on what we should do next? State our proof statement. We can go ahead and say that triangle JKN is congruent to triangle LMN. Who can tell me why? Other than Majay, because she's told me a lot. Caleb.
The SAS thingy.
The SAS thingy. Yes, I would not write the word thingy in a proof. You could just put side angle side. It is a postulate. Side angle side postulate works there. So again, we've got two pairs of congruent angles. Sorry, two pairs of congruent sides, and the included angles congruent to each other. Questions, concerns?
No.
Feeling good about our proofs? Not so bad?
Very easier this chapter.
Easier this chapter? Good. Okay. All right, let's talk about another theorem. Caleb, you got a question?
What?
You have a question?
No.
Oh, okay.
There's for Rodney.
Rodney's doing just fine over there.
I know you look
Okay.
nice, I asked him.
Okay. Are we ready for our next theorem? One person is. A few of us are ready. Okay. If the hypotenuse and a leg, hypotenuse, that's too small of a line for me to fit that on. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So in order to use this HL, or hypotenuse leg theorem, we need three things. What did they put in bold on this theorem? Right. We need to know that we have right triangles. If we don't have right triangles, we cannot use this. Next, we need what they told us in that theorem. We need the hypotenuses to be congruent. There's only one hypotenuse in any right triangle. So you just need each hypotenuse congruent from one triangle to the next. Last, we need, what else did they say other than hypotenuse? Legs. So we need one pair of legs congruent. In any right triangle, there are going to be two legs, so we are not going to use all three sides. We're only going to be using one of them. One of the legs from each. Does that make sense? We'll see that in our proof, I'm sure. Yes, ma'am.
Is the hypotenuse the one that goes directly up?
The one that's the hypotenuse is always across from the right angle. So if we have a right triangle, the hypotenuse is, well, that's close. If that's my right angle, then this side is my hypotenuse.
It doesn't matter what leg you use.
Nope. It does not matter which leg we use. The hypotenuse is specific, but we get to be flexible with which leg we're using. Other questions? These are good questions. Okay, we ready for another proof? They just keep coming today. I feel like the proofs this chapter are not nearly as challenging as the proofs in our last chapters. Mainly because once you've seen a few of them, they're pretty repetitive, right? We use bisectors, we use the reflexive property, we'll use vertical angles.
all you're doing is work out of it.
We're using
You
logic
have
and
the
reasoning.
question and the answer.
But you have to explain how to get there. That's part of geometry, is being able to explain yourself.
It's just like when, you know what I mean? It's just like, you know, some people don't do work and stuff. Like
And then they get a bad grade in math class.
No, I almost have an 80 now. I had a 70.
You don't gotta broadcast
4
it.
or 3.
But the
whatever it
reason
was.
of this is explaining our thought process. You have to be able to explain how to do this. You use your information, you make logical
It's
arguments.
just like an algebra. Like I don't do any work, but I still do things. But then
That is a wonderful skill. You should go into being a mathematician if you're so good at that.
does that mean I have to go to school?
Yes, if you want to be like a mathematician, like an actuary, you go to college and be an actuary.
After college, no more school.
Fancy told.
Well, yeah, you just go to college.
Uh,
Are we ready for this proof?
Yes.
After that small mental break, courtesy of Caleb. All right, we always start off with our givens. Yes, we are given a lot of information, which in my opinion is a good thing. The more information they give us, the more we have to work with. So we've got to list out all that given information. And then we'll go through and talk about how it helps us. What does that little symbol mean that we see a couple times here? Good, perpendicular. AC is the bisector of BD. Lots of givens. Of course, my reason for all of this is given. All right. AC is congruent to EC. That's pretty straightforward. We can go ahead and mark it in our diagram. If AB is perpendicular to BD, what does that mean to us?
ABC is the right angle.
Okay, we could say that this angle is a right angle. We could use 3 letters, or I'm okay if you just use one because there's only one angle there. So if you say angle B is a right angle. Similarly, we're told that BD is perpendicular to ED, so what does that tell us? Angle D is also a right angle. How did we know both of those, Ataya?
Wait, I got a question.
Sure.
Okay, so I started it and I said that B and D are right angles because definition of perpendicular.
That's what I did.
Yep, B and D are right angles. That's what I'm looking for my reason here. Is definition... Oh, what did you say?
No, what you said. I'm lost. Sorry. No, it's
Perpendicular
okay,
lines.
never mind.
We've got right angles, definition of what?
Perpendicular.
Perpendicular lines. Are we all good on that? Okay. And we could mark that over here. Now, you don't need to state, now that you know that those are right angles, you don't have to tell me that these are right triangles if you've told me that you have right angles. You can. It's just an extra step. Does that make sense? But if you told me you have right angles, you marked it in your diagram, then we know we have right triangles. So that part is taken care of. They also took care of which other part from those 3 things that were required? They took care of the hypotenuse. So we've got right triangles, we've got hypotenuses congruent, so the last thing we would need to use HL is legs congruent. Well, they gave us one more given. AC is a bisector of BD. So what does that tell me? Good. BC is congruent to CD. Why? Definition of bisector. We could go ahead and mark it in our diagram. And now we're ready for our prove statement. Ooh, didn't mean to do that. Now squeeze it in at the bottom. Triangle ABC is congruent to triangle EDCY. HL. We had right triangles, the hypotenuse is congruent, and a pair of legs congruent. Notice we didn't use A, B, or ED, and that's fine. They didn't talk about those, we don't need them. Questions, concerns, warm fuzzy feelings? No. Homework! Homework gives us warm fuzzy feelings, doesn't it?
Forget those.
Welcome, Yanni.